Hey class, it's Professor Bork. So I wanted to try to make a quick video for one of the questions that you could see in 10.3. So chapter 10 is all about hypothesis testing, right? So first it's difficult just to kind of get the different like language down and set up your like null and alternative hypotheses. That's one problem. And then another difficulty is whether or not you like reject or not, right? So there's a lot of things happening in chapter 10. 10.3 is focusing on means, right? So it's kind of similar to like 9.2, where you were involving like means. We're doing inferential statistics, right? So we're trying to take a sample and then use that to make a prediction about the population. So let's go ahead and read the question, see if we can work through this one together. It says a college entrance exam company determined that a score of 22 on the mathematics portion of the exam suggests that a student is college ready for college level mathematics. To achieve this goal, the company recommends the students take a core curriculum of math courses in high school. Okay, so that's all fine and well. That is going to be just from doing these a lot. I know that that is really telling me the score of 22 is the assumed to be true value. Okay, that is what they're saying is if you can get a score of 22, we're going to assume that that means you're ready for college entrance math. So that is just something that over time you kind of get used to spotting out is like which one's the null hypothesis, like what are we starting with and what are we to do from there. So we always usually we start with like whatever we assume to be true is 22. And then we're going to keep reading. So it says, suppose a random sample of 150 students who completed the core set of courses results in a mean math score of 22.6 on the college entrance exam with a standard deviation of 3.4. Okay, so that's a lot of information there as well. And that's usually how these are going to be set up. They're going to give you like this assumed to be true value that we're going to use to set up all our hypotheses. And then they're going to give you some sample data. So we have for this particular one, like little n equals 150, right? Because it says a sample of 150 students. So just kind of labeling everything. Then it says from that sample, the mean math score is 22.6. So what we would refer to that is then is X bar, right? X bar. I'll go ahead and add X with a little bar over top of it, equals 22.6. And then it also says that the sample standard deviation is 3.4. Okay, so I'll say S equals 3.4. So just to kind of get it all out, you're more than welcome to write it on your own sheet of paper, on some scratch paper, just to kind of keep everything straight. Okay, so then it says, do these results suggest that students who complete the core curriculum are ready for college level mathematics? That is, because I feel like on that alone, it's kind of tricky to see what they're really asking. Are they scoring above 22 on the math portion of the exam? Complete parts A through D below. Okay, so first things first, it says state the appropriate null and alternative hypotheses, fill in the correct answers below. So first it says the appropriate null and alternative hypotheses are, and then it has H sub 0 dot dot. Okay, so that is always how they will represent maybe like the original null hypothesis. Okay, and there's some drop down options. The drop down options that we have here are X bar or mu. So this could be confusing right off the bat because we know we're talking about a mean, but X bar can be for a mean and so can mu, right? So which one is it? So for all of these hypothesis testing, it's always talking about the population. Even though I know they give us sample data, we're trying to use that to make a prediction about the population. So if it's about means, it's the hypotheses will have mu in it. If it's about proportions, they'll have p, not p hat. Okay, so hopefully that kind of makes sense. So I'll say mu, and then there's another drop down option. It says less than or equal to, greater than, equal to, less than. So the null hypothesis is always equals to, always, because it's always what we're going to be assumed to be true. So the null is always equals. And then this is where we have to go back and see like, what was that original about they told us again? It was 22. So the null hypothesis we would say is mu equals 22. And then it says versus H sub 1 dot dot. Okay, so the alternative is we're trying to see if that we have like a significantly, like if it's higher. Okay, so we'll say same letter as in the null hypothesis, mu, and then they're looking for us to say that scoring above 22. So if they didn't rewrite that, that is, are they scoring above 22? I feel like I myself would be like a little unsure. Do they want us to say here greater than or greater than or equal to? I don't know. But because they said they're scoring above 22, not like at least 22 or 22 or greater, I'm just going to say greater than 22. But this is all continuous data. So when we're actually solving for it, the greater than or equal to or just greater than isn't really different. Doesn't matter. So just for this particular part, but greater than. Okay. So then it says verify that the requirements to perform the test using the teacher distribution are satisfied. So these are particularly annoying. This is where we have to like check up all the conditions. So we want to select the sample size is larger than 30 because that's very helpful. Sometimes sample size is less than 30. But that's why we use t-distribution. It kind of keeps us all on the same page. Also, it says that it was randomly sampled and the students' test scores were independent of one another. Okay, so those are typically what we're just looking for, whether you want to say either the population data is normally distributed, but we don't really know that yet, right? Because that's what we're trying to find out. We only know sample data. So we always want to look to see if the sample size is larger than 30, and the students were randomly sampled, and the students' test scores are independent of each other. Okay, great. Just ready to check them all off. All right, then it says, use the p-value approach at the alpha equals 0.1 level of significance to test the hypothesis in part A. Identify the test statistic. So your problem could have been slightly different. It could have had a different alpha level. They're going to give you the alpha level. And remember, alpha is supposed to be the probability of getting a type 1 error. Okay, because that's what we're trying to prevent. Type 1 errors are pretty bad. Like back to the court of law analogy, right? Like type 1 error would be finding someone guilty when they're actually innocent. Okay, so that's like rejecting the claim when you shouldn't have. That's pretty bad. You don't want to put an innocent man in or woman or whomever into jail for a crime they didn't do. The type 2 error is the other way around where they let someone guilty go free, right? And so that would be like, we were supposed to reject, but we didn't. Okay, so that isn't really necessary at all for this problem, but I saw some people write that they were a little confused about the type 1 and type 2 errors, which I totally understand. So alpha is supposed to be the type 1 error. So it's like, how important is this problem, right? Like I'd say like kind of important, but I wouldn't say it's like important in terms of like medicine for children or something like that, right? We're just talking about like test scores, which, are important, but in the scheme of the world, not the most important. So this one, they have alpha equals 0.1. Okay, so that would be the probability of getting rejecting when we shouldn't have. So long story short, we first start out by saying identify the test statistic. So you can do this using the formula by hand if you would like to, if you're brave, but I highly recommend using either StatCrunch or your graphing calculator. Top recommendation, StatCrunch. Next would be a graphing calculator. Okay, and so remember, if you ever are confused, please don't forget about the videos on Canvas. They can be particularly helpful to kind of guide you through like how to solve these in StatCrunch or the calculator or what have you. So I'm going to walk you through that as well. Okay, so first things first, what I'm going to do, I'm going to go ahead and do the hypothesis test. And from there, they're going to give you the test statistic. Okay, I really don't have to do much of any actual computing in these problems. It can all be done for me, it's just nice. Okay, so when we open up StatCrunch, we're going to go ahead and go to Stat, and then we're going to go to T-stats. So if these problems are a proportion problem, we go to proportion stats. If it's a means problem, we go to T-stats. Okay, and these steps, again, are going to be with you on your final exam. And so if you want to take a look at what those are going to look like, those are on the final exam information page and where you told me when you made your appointment. Okay, so we're going to go to T-stats, and then this is one sample. Chapter 11, spoiler alert, is just 2 samples right here. We're gonna go 1 sample, and then this is with summary. Okay, and I went ahead and had typed up here the information they gave us. I said n equals 150, x bar equals 222.6, and s equals 3.4. I'm gonna go ahead and erase that now because I'm gonna go ahead and type that in. Okay, so it says sample mean. The sample mean was 22.6. Remember, they said that was the sample mean for the 150 students. And then for this particular problem, the standard deviation is 3.4, and then sample size is 150. Okay, and then it says perform. So it says hypothesis test for mu. That's what we want. Okay, so the first one says H sub 0 mu equals, they even have it set up there for you. If you forget, when you're typing things into my math lab, StatCrunch will always has the equal to for the null hypothesis. That could be another way to help you remember. Okay, so we're basing this all off of 22. Okay, so I'm going to fill in 22 on the text box. And then it says the alternative hypothesis mu, and we're looking to see that is greater than 22. Okay, that was what we said for alternative. That's what they're looking to see. That is, are they scoring above 22 on the math portion of the exam? And then we don't have to click anything else. Just a little side note, you would go to, for a confidence interval, sometimes they also ask you to solve hypothesis tests like using confidence intervals like we did in chapter 9. And that would be in perform, you would just select the button right beneath it for confidence intervals. But we're not going to do that. We're going to leave it a hypothesis test, and then we can just click compute. And it tells me that it repeats one sample, T summary hypothesis test, mu, the null hypothesis, the alternative, and then there's a table. That's where we want to look. All the way to the right-hand side, it says T-stat. That would be my test statistic for this particular problem is the T-stat. It says round to 2 decimal places. So I'm going to go ahead and put 2.16. Okay. For proportions, if they ask for the test statistic, they use a Z, they'll use Z-stat. That's what you would see on proportion stats on StatCrunch as well. In like the same place you see here, T-stats. Okay, and then the p-value is 0.0161. It says round to 3 decimal places. So that would be, I'll say 0.016. Okay, so we're done now. Like we computed all the stuff and see how quick that was. That's why I recommend StatCrunch just because it's the quickest and easiest. You can use your graphing calculator. If you need any help with that, let me know. The videos on Canvas are helpful and walk you through it, but I can always make a video as well for that. And I like StatCrunch a lot. You can do these by hand, but again, I just really wouldn't recommend it because you're more likely to make like little mistakes with decimals and things like that. But if you want to, you're more than welcome to. Okay, now this is sometimes where it gets tricky. It says, write a conclusion based on the results. So from here, whenever we get out our p-value, the saying goes, when the p is low, you reject the null. Okay, kind of rhymes. Low, null, kind of. But that helps me to remember, like if the p-value is low, you reject the null. But like low, like what's low mean, right? Like 0.016, that's pretty small, right? So that's where we had to bring in this like lovely significance level. And told us before the significance level was 0.1. Okay, so then we have to compare, is the p-value 0.016, is that lower than 0.1? And sometimes it's actually kind of hard to tell because they're all decimals, right? Like it's kind of hard to compare decimals. You want to think like tenths place, hundredths place, thousandths place, right? 0.016 is less than like it's not even a whole tenth, right? It's 0.0 is in the 10th spot, right? And versus my alpha level has a 1 in the 10th spot. So the p-value in this problem is smaller than 0.1. And if you need any help with like comparing the decimal sizes, I know comparing decimals can be harder than you would think, right? Let me know because there are a couple tricks someone has shown me, students in the past have shown me like they multiply alpha by like 10 or 100, right? So if you multiply alpha by 10, just to see like that would be 1. Okay, and if you multiply the p-value by 10, it would be 0.16. And then you'd be like, oh, okay, yeah, 0.16 is definitely less than 1. You can do things like that to kind of help to figure out if the p-value is less than alpha. Okay, so hopefully we're all on the same page. P-value here is low. Okay, so that means we reject the null. That's the same. The p-value is low, which it is, you reject the null. If the p-value was not lower than alpha, we would not reject. Okay, so since the p-value is low here, we reject the null hypothesis and claim that there, and this is where if you reject, rejecting is the same thing as like finding someone guilty. If you find someone guilty, that means that there is evidence, okay, to support that they're guilty. That works for rejecting. Okay, so when we reject, that means there is evidence to could support the idea that the population mean is greater than 22, right? It's like there is evidence. Let me go ahead and add that in there just to kind of like, there is evidence to support the alternative. Okay, or the only other option That's option one, okay, is that we reject because there is evidence to support the alternative. If the p-value, let me go ahead and just make sure we cap this all together. There's option one, p-value is low, so you reject the null, right? To kind of the rhyme, not really, but kind of. Okay, there is evidence to support the alternative. Option two is the p-value is not low, right? Lower than alpha. So that means we do not have enough evidence. We do not find the defendant guilty, right? We're not saying the defendant's innocent, but we do not reject, do not find them guilty because there is not enough evidence um, to support the alternative. Right. So I feel like that's why they do kind of stress this whole like connection to the court of law in this hypothesis testing, because like logically, I think it kind of makes sense for us, right? We either find someone guilty and there's enough evidence to support, or we say that they're not guilty because there's not enough evidence, right? If you guys ever get called for the loveliness of jury duty, that would make a little bit more sense maybe. So for this one, we reject the null hypothesis, which is like the equivalent of finding someone guilty because there is sufficient evidence to conclude that the population mean is. And then for the last part here, we're talking about like there's enough evidence to support the alternative. Okay, and the alternative here, sometimes you got to go back and remind yourself, is that we're trying to say it's greater than 22. Okay, so if the p-value was not lower than alpha, we would say we do not reject the null hypothesis and that there is not sufficient evidence to conclude that the population mean is greater than 22. Okay, so I know this is a lot going on here, right? Between first is setting up the null and alternative can be challenging. Remember, it's either always mu or p because we're talking about population values. And the null hypothesis is always equals to, always. Always, always, always. Okay. And then the requirements, I know they're kind of annoying, but it's supposed to say that they're random and that they're independent and the sample size is larger than 30. Then to get the test statistic and the p-value, all we need to do is to go into StatCrunch and make sure we enter in the data for the sample data that they gave us, right? And just make sure that we enter in the null and alternative hypotheses like we just kind of entered. And then once we have out the p-value from there, it's either it's low, which means we reject, there is evidence. Or the other option is it's not low, we do not reject, there is not enough evidence. Okay, so I hope that was kind of helpful. Again, I know it's tricky, but please keep me posted. Feel free to come see me in my office hours tomorrow if you're able, but if those hours do not work for you, then just let me know. We can find another time. Okay, thank you, class. I'll talk to you soon.